Hello everyone. In this lecture, we will see what is F statistic, what is F distribution associated with this F statistic, and not in much detail we'll talk about the distribution, PDF and CDF of that, but we will learn to how to use F table for finding F statistic values for the given constraints on probability. After that, we will be starting with hypothesis testing and some basic definitions in the area of hypothesis testing. So let me share my screen. I hope this screen is visible to all of you. So myself, Dr. Yogita Mahatekar from Department of Mathematics, COEP Technological University. Let us quickly go into the basic definition of F distribution. So F distribution is defined as the ratio of two chi-square distributions, ratio of two chi-square statistics. So let x and y be independent chi-square m and chi-square n distributed random variables. So chi-square m is the chi-square statistic with m degrees of freedom, and chi-square n is another chi-square statistic random variable with n degrees of freedom. Then the ratio of these two random variables, x by m upon y by n, is following F statistic with 2 degrees of freedom m comma n. So this statistic follows Fisher F distribution with m and n degrees of freedom. PDF of F distribution is given. We are not going in details of definition of probability density function for the statistic. But you should understand, as chi-square is not a symmetric distribution, F statistic being a ratio of two chi-square distributions, it is not a symmetric distribution, it is non-symmetric distribution. So the nature of probability density function of chi-square statistic is like this, as shown in the figure. Let us go ahead with the application of F distribution. So F distribution relates the ratio of two sample variances of two independent samples of size m and n, where such samples are identically independent samples from the normal population. Okay, so the samples are taken from normal population. So you take two samples, find their variances. So Sx square is the sample variance of the first sample, Sy square is the sample variance of the second sample. Take the ratio, it will form F statistic with 2 degrees of freedoms, m minus 1 and n minus 1. So why this Sx square and Sy square is the ratio of 2 chi-square? Because we already seen that S square follows chi-square distribution with n minus 1 degrees of freedom, 1 degree less than the sample size. So if m is the sample size of first sample, then Sx square will be chi-square distribution with m minus 1 degrees of freedom, and Sy square will be the chi-square distribution with n minus 1 degrees of freedom. And the basic definition of F statistics says that if we take ratio of these two chi-square distributions, then they form a F distribution with m minus 1 and n minus 1 degrees of freedom. So you should understand that F statistic comes with 2 degrees of freedom. Now this theorem is very important regarding F distribution. So this theorem says that if m and n are strictly positive integers, and if x random variable is f random variable with n and m degrees of freedom, where f and m is F distribution with n and m degrees of freedom, then 1 upon x, I mean if we take the reciprocal of this f and m, it is equivalent to f m comma n. So what this tells you is that, so this theorem is also called as the reciprocal rule, because we are taking the reciprocal of reciprocal of x. So 1 upon x is equivalent to F statistic with m and n degrees of freedom. So in other words, equivalently we can write that 1 upon f n comma m is equivalent to f m comma n. So you have to flip the order of degrees of freedom when you take the reciprocal of F distribution. So we will be using this reciprocal rule while solving the examples. In the next slide, let us solve these examples using statistical tables. Okay, so let me just expand this window so that it is visible properly. Now this first example is asking you that you have to find out the value of F statistic f 0.05, f suffix 0.05 when degrees of freedoms are 7 and 50. Okay, so using statistical tables, you have to solve this first example. So let us see how will you solve this example. So let me go to the desktop and open my statistical table. So if I open this statistical table, then you will understand that at the top of this table, it's written that you have given the critical values of f distribution, where the suffix of f is 0.01 over here. Nu1 and nu2 will be analogous to m and n, which represents degrees of freedom. So nu1 is 1, 2, 3, 4, 5, 6, 7 till 9, which is first horizontal row, and nu2 is 1, 2 up to infinity, which is the first vertical column, which represents the second degree of freedom. Okay, so this is critical values of f distribution for 0.01 as a suffix of f is written over here. So let me just go ahead. Let me scroll up. So now you can observe here carefully that the suffix of f is 0.05. So in which we are interested right now in the example. Okay. So you have given 7 as the first degree of freedom and 15 as the second degree of freedom. Let us denote it by nu1 and nu2 in the table. So if I still scroll it up, I will get nu1 is equal to 7, which is over here. So let me just mark that 7. Okay, so nu1 being the first degree of freedom is 7 and nu2 being the second degree of freedom is 15. So you just mark this column for 7 degree of freedom as nu1 and mark this row which is for nu2 is equal to 15 degree of freedom, and the intersection is 2.71. Now look at this table, this figure. So above the table, so it represents f alpha over here, right? So what it tells you that for 7 and 15 degrees of freedom, 2.71 is the value, which is f value of course, which has its right hand side area to be 0.05. Okay, this right hand side area is 0.05. So the answer to the first question is 2.71. Basically this first question and the second question is same. Now let's go towards the third question. Now you have to find f suffix 0.09, 0.99 when degree of freedom is 28 and 12. So I'll say that nu1 is 28 and nu2 is 12. Okay, but the suffix at the same time is 0.99. So you should understand, or first of all note that f tables are available. So whatever statistical table I'm following right now, for that f tables are available only for alpha is equal to 0.05 and alpha is equal to 0.01, which are written as the suffix of f. Okay. यश बोलता था का? हाँ हाँ बोल. काय रे तुला? बरोबर. So now for the third example, f 0.99. It is very difficult to use statistical tables because they are available only for 0.05 and 0.01. So we should use the reciprocal rule over here. So for this third example, f suffix, which is the answer of 3, f suffix 0.99, we will be writing as 1 upon f suffix 0.1 minus alpha. So basically it is the reciprocal rule is, let me write it over here, f alpha with nu 1 and nu 2 degrees of freedom is 1 upon f 1 minus alpha for nu 2 and nu 1 degrees of freedom. So here we should take 1 minus 0.99, 1 minus 0.99, I'll write directly. Now here you are having how many degrees of freedom? 28 and 12. So this is for 28 and 12. And here it is, I'll be taking the flipping of those degrees of freedom as 12 and 28. Okay. So now therefore this is 1 upon f suffix 0.01 for 12 and 28 degrees of freedom. Now let me switch on to the statistical tables. So now here my statistical tables for 0.05, there are 2 pages, and now I'll be going 0.01. So here you can see. So here you can see it is for 0.01. Now for 12 and 28 degrees of freedom we have to see. So let me scroll it still down. Now for 12 and 28 degrees of freedom, my intersection of that row and that column is 2.9. Okay, so this is 1 upon 2.9. So the answer for this question 3 is 1 upon 2.9. So 1 upon 2.9 is that f statistic value for which area to the right hand side of that value is 0.99. So therefore the third example is solved. Similarly, so let me just draw the answer for question 3 pictorial. So what it says is, this is 1 by 2.9, whatever is the answer. And after this, the 99% of the area lies to the right hand side of that. After that, let's solve question number 4. Now you have to find out f suffix 0.01 when the degree of freedom is 24 and 19. Okay, so when the degree of freedom is 24 and 19, when the degree of freedom is 24 and 19, now you have to go for nu 1 is equal to 24 and nu 2 is equal to nu 1 is equal to 24 and nu 2 is equal to 19. So this is, suppose, this column and this row, and hence the answer is 2.92. Okay, so answer for this question 4 is 2.92. Okay, so this is how to make use of F tables for solving basic mechanical examples in using F statistics. So let us go ahead with the testing of hypothesis. So in this topic of hypothesis testing, hypothesis testing is regarding if some experimental analysis if you are doing, and with the help of given data you are arriving at some conclusion, you will be putting on your hypothesis. So that hypothesis, whether it is correct statistically or not, is very important. So therefore we will be using the testing of hypothesis concept for testing whether our hypothesis is true or false, or making statistical inferences out of that. Okay, so here there are two problems basically where we have to deal with them. The first one is one sample problem and another one is two sample problem. So in one sample problem, what we do is we have, suppose the large population, we take a very small sample which is easy for handling on the human level, and then we'll be drawing some conclusion out of that sample that we are testing. Okay, so when we test the sample, for example, suppose I am having university, and at the university level, whatever admissions of first years are going to happen, I'll be having that particular big mob with me. Now suppose I'm interested in what is the average number of marks that students have got before taking the examination, before taking the admission, before examination. How many marks, what is the average number of marks the particular student have got in the first year of BTech. Suppose he's taking admission in the first year BTech. So what we'll do is we'll take the small sample of students from some division, say, and we'll be taking the average of marks. And with the help of that, I'll be putting in a hypothesis that the average mark the particular student's class is equal to, say, 70 out of 100. Now I have to check whether this hypothesis that I'm making is true for the large population or not. This is what is called as testing of hypothesis. Now there is the systematic way to test the hypothesis that we are going to put it on. Okay, so this is regarding one sample, and suppose you are having two samples from the same population, then we will be having comparison. We may comparison the different statistical parameters that are dealing with those two samples. For example, suppose we are having two samples from the same population, then the variance of the first sample may be less than the variance of the another one. So we will put on such a hypothesis and we'll be testing for whether it is statistically true or false hypothesis. Okay, so with this, so in one sample problems, the data is usually assumed to arise from one sample from the defined population. In two sample problems, data originates from the two samples, possibly from two different populations. So it's not important and it is not mandatory that in two sample problems, your samples are from two different populations. Okay, so they can be from the single population or they may be from two different populations. The heterogeneity is often modeled by assuming that two populations only differ in some parameters or key qualities such as expectation, median, and variance. So as in our example that I'll be taking it after some time. So let us first of all cover a few basics regarding testing of hypothesis. Now there is H1 and H0, which stands for, so H0 is the null hypothesis. So H0 is the notation that we'll be using for null hypothesis, and H1 is the notation that we will use for alternative hypothesis. So alternative hypothesis is the hypothesis that we want to test. Okay, so generally, so basically it's not mandatory that alternative hypothesis or the statement we are making on based on the small sample, it has to be always the statement that we want to test. But as per the convention of some statistical books, I have understood that the alternative hypothesis H1 should be the statement that we want to test. Okay, statement we want to test. And H0, namely null hypothesis, is the negation of whatever statement we want to test. So this is how is the convention of H0 and H1. So here one can see that delta B I'll be taking as some parameter which is with the sample B, say, and delta suffix A stands for the sample with respect to parameter with respect to sample A. So if you want to test that the parameter of sample B is greater than the parameter of sample A, then the negation of the statement is your null hypothesis. Okay, so always the thing is that first of all you should define your H1 and then you should be defining your H0. Now there are two types of tests while testing the given hypothesis of the statement. One is one-sided test and another type of test is two-sided tests. Okay, so it depends on how you are going to define your alternative hypothesis. So if you are saying that your alternative hypothesis is having inequality, say for example theta is the parameter which is involved with your samples, and now we are looking for single sample tests. Okay, so there are three single sample tests that we are going to learn hereafter. The first one is Z test, another one is chi-square test, and then t-test. So theta naught equal to theta naught, if you have inequality in alternative hypothesis, we'll call it as a two-sided test. And if you are having strict inequality in your alternative hypothesis, then we'll be calling it as one-sided test. I hope now the question is clear to all of you. Now let's see this example. So one sample problem we are going to deal with right now. Suppose your null hypothesis is average filling weight of packages of the floor is 1 kg, or your null hypothesis might be like average body height of the man in some sample of some population is 178 centimeters. So these are the null hypothesis examples that are given over here. And the alternative is formulated as the deviation from the target value. So if the deviations are in both the directions, then H0 is called as two-sided hypothesis. This we have already seen. So if I say that H1 is average body height is not 178 centimeter, then we'll call it as two-sided testing of hypothesis because the inequality is involved. And if the deviation is towards one particular side of the value, so if I say that H1 is the average filling weight of the 4 kilo of the floor package is lower than 1 kg, I mean less than. So here we are arriving at strict inequality, or will if we may state it like H1 basically. Okay, so we are talking about alternative H1. So if I say that it is greater than, then we call it as one-sided test of hypothesis. Okay, so this is how it goes. The another definitions are very important definitions in this context of testing of hypothesis. So if we undertake statistical tests, then two types of errors can occur. The first is called as type 1 error and the another one is called as type 2 error. So now let's see what is type 1 error. Okay, so now this is your fact. So what is your fact? Fact is that H0 is true or H0 may not be true. Okay, and what decision you are making? So these are your decision. So your decision might be like H0 is not rejected, or the another possible decision is H0 is rejected. Now you should understand that your fact and decision should match. So when it match, it says that you are around the correct decision way. Okay. Now when H0 is true and your decision is H0 is not rejected, you are on a correct path and your decision is correct. Okay. Now in the second cell, if H0 is not true and you are not rejecting, then you are making a kind of error and it is called as type 2 error. Okay. Now the third fact is, look at the cell of type 1 error. Now what is type 1 error? If H0 is true but you are rejecting. See, when H0 is true, you should not reject. When H0 is true, you should accept H0, right? But you are rejecting. So in that case, your decision is not matching with the fact, and then we say that you are making type 1 error. And the last cell is correct decision. What it says is if H0 is not true and if you are rejecting, then you are at the correct path of decision and your decision is correct. Okay. So this is how to define type 1 error and type 2 error. So what is type 1 error? Type 1 error is H0 is true, H0 is rejected even if it is true. Okay. And type 2 error is H0 is not rejected even if it is not true. So this is how type 1 error and type 2 error is defined. Now let's see this example. Now suppose an allergist wishes to test the hypothesis that at least 30% of the public is allergic to some cheese product. Now you have to explain how allergist could commit a type 1 error and a type 2 error. Okay, so you have to write your answer in word form. So let's write the answer. So what is type 1 error? So type 1 error is, just now we have seen the definition. So type 1 error is H0 is true but it is rejected. H0 is true in fact but is rejected. So this is what is type 1 error. So what allergist could commit? So allergist could say, I mean he should reject H0 even if it is true. For that, first of all you define what is your H0 and H1. So what is your H0 and what is your H1? I already told you that the hypothesis that we want to test is taken as H1. So let's say that greater equal 30% people are allergic. This is your H1. And H0 is less than 30%, strictly less than, are allergic. Right. So this is your H0 and H1. Now you are rejecting H0. So what you are rejecting H0 means you are accepting H1. So when allergist. So answer is allergist could commit that greater equal 30% are allergic, but less than 30% are infant. Okay, so in this case, we are making, or that allergist is making type 1 error. And how we can make type 2 error? Similarly, how will you say say what allergist could commit so that he is making type 2 error? So type 2 error means what? Type 2 error, look at this diagram. Type 2 error means H0 is not true, but it is not rejected. Okay, so you are not rejecting H0. So allergist could commit that less than 30% people are allergic, but greater equal 30% are allergic in the fact. So that is what is type 2 error. Now in this session we'll stop here right now. Hereafter we'll continue with the next topics on testing of hypothesis. Thank you.